Hi, today we're going to be talking about different type of roots. You've done square roots before in the past. Today we're going to be talking about cube roots and fourth roots. And then the roots can go on forever, but we will just be focusing on cube roots and fourth roots. The rules apply like they do with square roots. So problems A, B, and C are the same under the radical, under the cube root, and under the fourth root, but how we simplify it is going to change based on what the root number is. So 48x to the fifth, y to the third, taking the square root of it, we're going to tree it down like we have in the past. So 48 is 6 times 8, 2 and 3, 2 and 4, 2 and 2. So in the end, we have 48 is equal to 4 2's and a 3. X to the fifth are 5 x's, and y to the third, 3 y's. So because this is the same for all three problems A, B, and C, I am going to copy this for all the problems. Okay, so going back to problem A square root means pairs of 2. So we have 2 pairs of 2, 2 pairs of x's, and 1 pair of y's. So the 2, the x, and the y come out, and they all get multiplied, one of each, and that's going to make 4x squared y. The leftover 3 and y stay underneath. So that's what we've done in the past. So cube root, if we go to the definition, cube root means that it's a number when multiplied by itself 3 times gives the value under the radical. So therefore, where square roots we're thinking of pairs, cube roots we're thinking of triplets. So now we want to circle triplets, pairs of 3. So we have a pair of 3 2's, we have a pair of 3 x's, and we have a pair of 3 y's. So again, just like before, one of each pair come out. So we have a 2, an x, and a y group come out. And then the leftovers stay underneath the cube root still, just like before. You have to make sure you put a little 3 there. Without the 3, it signifies a square root. So the 3 there signifies a cube root. And then the leftover 2, 3x, and x makes 6x squared. Okay, and then when we get to fourth root, again, if we read the definition, is the number when multiplied by itself 4 times equals what is under the radical. So now we're trying to group things in 4's. So we have 4 2's, we have a group of 4 x's, and that is it. So your 1 of each group comes out, your 2 comes out, and your x comes out. And then the leftover 3x, y stay underneath. Again, make sure there's a little 4 there for the fourth root. So you have 3x, y cubed. So that's the same expression, but take in the square root, cube root, and fourth root, and you can see the difference that happens. Okay, letter D. So we want to take the cube root of x to the 9th, y 12th over negative 8. So in this particular problem, we have a fraction, and you can simplify this like you did A, B, and C. When it's a fraction, you're going to do each piece where it is. So you're going to do x to the 9th, y to the 12th, and then negative 8. So x to the 9th means there's 9 of them. Y to the 12th, there's 12 of them. And then negative 8 is negative 2 times negative 2 times negative 2. Now, if you didn't know what the cube root of negative 8 is, let me help you understand how to use your calculator. On the 84, you do second math. Oops, sorry. You only press math. And there is a cube root key. It's number 4. And then you can just simply type it in also if you did not know what the cube root of negative 8 is. If it's not a decimal, though, you couldn't do it this way. On the 84, just hit second and the radical key, and I'll show you what it looks like. When you hit second and the radical key, you're going to get this symbol over here, but this will be a box. And then you're going to put the number 3 there. And that means cube root of negative 8. Okay, so cube root means I need groups of 3. So we have perfect number of groups of 3. Therefore, the cube root symbol will go away. X, and X comes out, and it's x cubed. Y, and Y come out. That's y to the 4th. And then it's a fraction, so put it over. And then the group of 3 negative 2's, one of them comes out, and it's over negative 2. Okay, and lastly, E. When you are subtracting square roots, cube roots, fourth roots, you have to simplify and have like terms, just like we've done in the past. So for these letter E, we're going to have to break down each of those cube roots because they are not like. And then if they're like, we can then combine them into one term. All right, so 250. 250 is 25 times 10. Okay, so it's 5525. And then x to the 4th. And then y to the 3rd. All right, 16. So 16 is 4 2's, x to the 4th, and y to the 3rd. All right, so we're dealing with cube roots, so we have to do groups of 3. So the 250 has a group of 3 5's, a group of 3 x's, and a group of 3 y's. So the 5, x, and y come out. And the leftover 2 and x stay underneath the cube root. For the other term, we have a group of 3 2's, a group of 3 x's, and a group of 3 y's. So the 2 comes out, and the x and the y come out. And then we have a leftover 2x underneath the cube root. Okay, so these are in fact like terms, and I'll show you again. Like terms are if you take everything after the front number, they have to match exactly. So the yellow groups are a match, so 5 yellows take away 2 yellows, mean that there are 3 yellows left. And the yellow group stays exactly the way it looks like. All right, one more thing you have to learn today, besides trying to break down cube roots, fourth roots, and then subtracting them and adding them and such, is we are now going to deal with them as a power. You are used to having powers that are only whole numbers, but powers can also be fractions. So I'll do problem 1A first so I can explain and talk about what the pieces mean. When you have a fraction, it means that there is a combination of a power and a root involved. And if we go to our notes, the top number is your power and the bottom number is the root, like square root, cube root, fourth root. Now you most certainly can do problem 1A in your calculator, and I can even do it right now with you. But I want you to understand what the pieces mean. Okay, so we're going to type in 16 to the power fraction 3/4. And you get 8. So that's going to come out to be an 8. But why is it coming out to be an 8? That's the question. So if we look back at our problem, the 3 represents a power, and the bottom number represents the root. When you're trying to understand what's going on, it's better to take the root first. So what this is saying is that we're going to apply a power of 3, and then we're going to also apply a fourth root on this number. You can do either one you want first, but I would much rather take the fourth root of 16 first than to try to raise 16 to the third power and have a huge number and have to deal with that. So you can do either one first, and that's what this means right here, that you can either do the power first and then the root, or you can do the root first and then the power. All right, so 16, if I break that down, is 2 times 2 times 2 times 2. So if I do the fourth root first, the fourth root means groups of 4. So I'm going to do this first. And I have one group of 4 2's. So if I just take care of this, that means the fourth root, and that's going to end up being 2. And then I still have the 3 power to deal with. So 2 to the third power means 2 times 2 times 2. And there's our 8 that we got in our calculator. All right, so B, I want to simplify that. Your exponent laws from last class are going to apply. So when we have a power on the outside, regardless that it's a fraction, we know that we can distribute it in to all the terms as long as there's not an addition or subtraction sign in it, and there's not. We also have a negative on the outside. So we're going to first take care of the negative because it's best to get rid of that first when you have a negative on a group. A negative, if you recall, as a power means to flip. So that negative means we're going to flip the term to the bottom because it's on the top. So the 8x to the third, y to the ninth group is on the bottom. So we put a 1 here. And that means that we keep the power 1/3, but we take off the negative because that's what the flip does. So now we're going to bring the power, which is a fraction, and the 1/3 power has to go to all the items in the group. So that's going to be an 8 to the 1/3 power. And then you're going to do 3 times 1/3. And then you're going to do, oh, excuse me. That's going to be x. You're going to have x to the third times a third. And you're going to have y 9th times a third. So the 1/3 power gets brought to each term. And then an 8 to the 1/3 power means the 3 is a root. That means third root. If you don't know it, we can either do 8 is 2 times 2 times 2, or you can do 1/3 power by doing 8 to the power 1/3. And it's 2 because there's a group of 3 2's in the number 8. 3 times 1/3 is 1. So that's going to be x to the 1. And y to the 9th times a third. 9 times 1/3 is 3. Okay, so in the end, it's going to equal 1 over 2xy to the third. All right, so problem 2. So all your rules with your fractions apply. You just like when you multiply like bases, you add powers. When you divide, you subtract powers. All of those rules apply. Just the meaning of the fraction is new. Again, power is the number on the top of the fraction. The root number is the number at the bottom. So number 2, we want to rewrite the expressions using a radical symbol and only having positive powers, exponents. So this is the power. This is the root. So if you have to change forms, it means that the root number is 3 and the power is 2. So x squared would be the power. And the root symbol is a 3, so you put a little 3 here, and that means cube root. Without a number there, so if we go to, and I'll highlight it. Without the number, that's your basic square root. And that means that the root number is 2. So that's the only one where the number it doesn't show. That's like your default. Every other one will have like a number, and that's the number that's in the bottom of the fraction. All right, so B, we have 3 things going on. We have the power, that's the root, and this is the flip. So we have the x is going to be flipped to the bottom. We have a power 3, and then we have a root 4. And that's what B would look like if we changed forms. Okay, 2C. This one has a minus sign. So you cannot distribute the power to the terms. So that means that this chunk is going to stay together. So x squared minus 4. Then we have a power 3 on that entire group. And then that is the root number. Okay, and we'll try a couple more. I think I'm going to do a couple practice problems with you from your practice pages. Number 3, rewrite each without the radical using only positive exponents. So now this is the problem where it's number 2, but the other way. We're going to start with the radical, and they want us to go back to the exponent form of it. There's several ways to do this, but basically this 4 here means it's a root. So that means it's a 4 on the bottom. So if we distribute that 4 on the bottom to all 4 terms, it'll look like this. 81 originally had a 1 power on it because there's no power. And then we have to put the 4th root on that. X squared, we're going to take the 4th root of that. And then y to the 5th, we're going to take the 4th root of that. And then 81 to the 1/4 power means that what's the 4th root? What number 4 times makes 81? Again, if you don't know that, you can use your calculator, but it is going to end up being 3. And x to the 2/4, well, all we can do is reduce it. 2/4 reduces to a half. And y to the 5/4, well, you can't reduce that. So that is what that would look like in exponent form. In letter B, we have a 6th power. Okay, so that 6th power needs to go to all the terms. And then we have a 64, a 1 power originally, a 6th root is what we're putting onto it. X to the 5th, we're going to take the 6th root, and a y squared, we're going to take the 6th root. So 64 to the 1/6 power means what number 6 times itself gives you 64. This one may not be so obvious, so we'll do this one in your calculator. I believe it's 2, but we will look. and it is in fact 2. And it may not come out to be nice, but it did. X to the 5 6 can't reduce, and y to the 2 6 is 1/3. Okay, so I'm going to go to the practice pages. And, oh, I'm sorry. We have to do one more item. We need to learn now how to solve when we have a fractional power. All right, now solving just means that we are going to get the x all by itself. And in order to get the x by itself, you have to think about unraveling everything. Well, problem number 1, everything is gone except for the power. So we have to ask ourselves, well, how do we get rid of a 2/3 power? Because if we get rid of the 2/3 power, then we have x by itself and we solved for x. Well, to get rid of a power, a fractional power, what you're going to do is take the reciprocal power of both sides. So the reciprocal power of 2/3 is 3/2, because power to power you multiply, and when you multiply reciprocals, they make a 1. So 2/3 times 3/2 will make an x to the 1. And whatever you do to one side of the equation, as long as you do to the other side, you keep the equation balanced. All right, so we're going to take 4 to the 3/2 power. Again, we can do this really quickly in our heads, just this one last time. The 2 on the bottom means the root is 2. That means square root. Well, the square root of 4 is 2, and then 2 has to be raised to the 3rd power. Well, 2 times 2 times 2 is 8. So it's going to end up being 8. And again, if you don't want to do them in your head, I just wanted you to get some number sense with that. You can do it in your calculator. And you'll get 8. So problem number 2, in order to get x by itself, we have to take off all the pieces away from x and you work outside in. So before I can do the reciprocal power, I first have to get rid of the +1. And you do that by subtracting 1. Now the only thing left to get rid of is the power, and to get rid of a power, I take the reciprocal power. So the 3/2 times the 2/3 are reciprocals. They'll make 1. And then 8 to the 2/3, you can do that in your calculator, but it's going to end up being 4. Okay, number 3, again, in order to get to x, I got to start taking things away from it first. The first thing I need to get rid of is the +3. You always work outside in. So we're going to subtract the 3 over. And then to get to the x, I still have this 2 to get rid of, and that's a times 2. So the opposite of times 2 is divide 2. And then to get rid of the power, that's the last thing left, we take the reciprocal power. Now please note, the reciprocal power does not mean negate. Therefore, I'm going to flip -1/4 and get -4/1. So we're going to raise both sides to the -4/1. Reciprocal does not mean negate. So the negative will not, we can't get rid of that negative. So we're going to have a 1/2 to the power -4/1. Now -4/1 is just -4. So I'll just do -4. And we get 16. Okay, problem number 4. Well, in order to get rid of those pieces, this is why we need to know how to change forms. It's not really practical to work with the problem 4, the 3rd root of x squared. So we're definitely going to want to change forms because it's much easier to work with the exponents, because we have exponent rules we can use rather than working with the cube roots. So a 3rd root of x squared means that it's x to a power 2 root 3. So that changed forms is x to the 2/3. Once we change forms, now it's much easier to solve because I can do the reciprocal power to both sides. to get rid of that power on the x. And again, you can do this in your calculator. 16 to the 3/2 power will end up being 64. Okay, and number 5 looks really hard, but it's not as hard as it looks. If you understand solving is just peeling off the pieces, we have a lot of pieces to get rid of in order to get to that x. Outside in, first we get rid of the 2 by subtracting it over. Next, we have to get rid of the 3 by dividing it over. Okay, next we have to get rid of the power 2/3 by raising both sides to the reciprocal power 3/2. That will eliminate the power here. And you have a 2x plus 3 left. We no longer need parentheses anymore because we got rid of the thing that was keeping the group together. And again, on the other side, you can put that in your calculator if you don't know, but this means the square root of 25, which is 5, raised to the 3rd power is 125. And now we have a simple equation. We need to get rid of the 3 and then divide by 2. Okay, so I'm just going to do a couple more of the conversions since I know that tends to be the more difficult part. So I'm going to go to the practice pages and skip the initial simplifying since those are a little bit easier. And just maybe do just a couple of each, either 8 to 10 and 11 to 13. So on 8 to 10, you have to convert these back to having exponents, and you just have to be careful of which term has the root on it and which terms don't. So on problem 8, we have the -2. That didn't change. On problem 8, the only thing that's changing is the radical x to the 5th. We have a power 5, and since it has a root on it, we know we have a fraction, and the number on the root when it's not there is a 2. So that's what number 8 would look like. Number 9, again, the x is not being touched. The only thing we're touching is this. So we have a y, we have a 3 power, and again, there's no number on the root, so it's a 2. And number 10, the 5th root is going to all of that. So if the 5th root is going to all of it, we need to understand that we're going to put a 5th root on the a squared term and the b term, which has a 1. And 5th root means it's a divide 5 on the bottom. And that's what that would look like. Okay, problem number 11, 12, and 13. I'll just do those really quick. We have to convert back to radical form and only have positive powers. So power, root. Okay, so we have a fraction, so we know we have a root. The x is the base, the 5 is the power, and the 2 root goes here. But we don't show a 2 root. That's awkward, so we just leave it off, and that means square root of x to the 5th. This right here means to flip, so I know I'm going to have an m to the 2/3 on the bottom. That got rid of the negative, and now I can take care of the fraction. Because there's a fraction, I know I have a radical. The m is the base. 2 is the power, and the 3 is the root with a 1 numerator. And on 13, the a is on the outside. The 5/3 is only going to the b. So a is on the outside. The fraction is only on the b. So I know I have a radical with a b underneath. The 5 is the power, and the root is 3. Okay, now you can try some on your own if you wish.